So it was a while ago I built my first electric go-kart, or electric trike in this case, and it went really fast, as you can see in this video clip. Now that was powered from four 12-volt lead-acid batteries that should be able to put out about 100 amps each. I recently tested one of these batteries and found out that instead of 100 amps, I'm actually getting 3. Which explains why that was so abysmally not exciting and the trike was so slow. So, I've bought a new battery and I'm going to do some new tests, but I realised my fundamental problem is even with 4 lead-acid batteries I'm running 48 volts, and 48 volts doesn't help me when the motor is 180 volts, rated at 10.5 amps, so it's 2.5 horsepower motor, and it should give me some good go juice, but it didn't, and again, not 100 amps, 3, these batteries are dead. So I reckon if I can pull about 100, let's say 100 amps, at 12 volts from a lead-acid battery that is within spec for the one I've got, I should be able to pull, a good amount of energy and power out of that motor. And I should be able to go from there to whee quite easily. But there's the problem. How do you go from 48 volts up to 180 volts? Or, as I'm kind of hoping, how do I go from 12 volts up to 180 volts? Well, I have a prototype. This is my treadmill motor, and it's currently running at... I must not smack my head against this, it'll hurt. Ooh, ow, my hand. Here you go. So we're running about 12 volts. And 160 milliamps from one supply, so that's what? No, 320 milliamps. So it's not a huge amount of the power supplies in parallel. But I have my boost converter. Now, a boost converter is awesome, and I'll give a better of a description on how it works later on, but critically, a boost converter allows you to go from a low voltage to a high voltage, sacrifice that you pull more current. Let's say my motor pulls 10 amps, battery supplies 100 amps, that's 10 times more current for 10 times more voltage, so I go from 12 to 120. Now, my bench supply can only supply 6 amps set up in its parallel configuration, and I'm okay with that. That's fine. This is just a prototype. As I say, I've got a battery on order. Once that's in, I'll connect it onto this. But critically, I should be able to get the motor to run faster at a higher voltage for the same DC input, so for the same 12 volt supply, and we'll see what I get. Okay, this is my electronics bench. It used to be quite a bit bigger, but I downsized, and I'm shrinking my collection of expensive engineering resources, or as the wife calls them, junk. Here's all my test equipment, here's my test rig. So, motor, that's, as I say, 180 volts, 10.5 amps. I've got an output capacitor for the boost converter. This is a nice wound inductor. It's Litz wire. You've got a little diode in here, nice big heatsink and fan, power terminal. This is, as I say, a prototype. I will track out a nice PCB at some point, so it's all not a horrible tangle of dangerous wires, especially considering 180 volts. And a capacitor that size, that's going to vaporize some stuff, as I found out when I shorted it out and woke everyone in the house. Yeah. Anywho. 12 volts. And this is the motor supply. This is the bench supply. This is the signal generator, and we're running at about 100 kilohertz. And we're running 1% duty cycle at the moment, so I figure let's just try. Let's put this up to 10. So that's 10%. No change. But you can see current spikes. Oh yeah, I have a clamp meter. I have a clamp meter running on that. So 10%, not a whole lot. Wow, the contrast on this is terrible. 80%. Now, ooh, 12.7, 12.4. We have a higher output voltage than input. I do think this should be running faster than it is. I don't know why it's not. Should we just go up to 50%? Let's go up to 50%. Okay, so we're now pulling more current. Significantly more. I mean, still about an amp and a bit between the two supplies. That's fine. But I can hear the motors faster and I can hear the cooling fans slowed down. That's going to be through DC losses in the cable, connections, again, janky rat's nest of wires. Not the best. Bing! But oh look, 25 volts. 12 volts in. 25 volts out. 12 volts in. 25 volts out. Now imagine I was running this at 48 volts. Well, 48 is almost 50, and in fact on a lead acid battery for them is going to give me about 50 volts for the bank. So now I'm at 100 volts. This is a good sign, and I'm still only at 50%. %, 70%, 80%. So we're pulling just a touch over 3 amps. Current waveform good. 36 volts, and about 3 times. Okay. Let's just go straight 95%, see how high we can push this. Okay, we're getting up to the 6 amp limit. I can hear it's getting faster. And we're almost there. Bing! 49 volts. 49 volts at the 3 amp limit. Yeah, the moment I load this up, the power limit of the power supply is going to kick in and it's just going to shut down. Yeah, let's try that. I mean, don't do this at home. This is a good way to lose a finger. If you don't believe me, Google degloving. If you're squeamish, don't Google degloving. Ooh. Yeah, power limit. Tell you what, let's wait till I've got the battery, and we'll retry then. Let's take it up to 96%, see if we can hit 50 volts. Ah, beautiful. 55 volts from a 12 volt supply.